Good morning.
Good morning, sir.
No. Yesterday's class, we were left with some part of semiconductors. Among them, the three important things are photodiode, the photovoltaic cell, solar cell, and LED. Maximum questions that they have given us are from photodiode. But mainly they ask for advantages and disadvantages of photodiode. The question bank says advantages, disadvantages of photodiode, but we'll deal with the working as well. Listen, basically photodiode, few things you'll have to just remember here. So the complete mechanism actually involves little bit of a quantum mechanics. So they also don't describe the complete thing. This is the anode. This is the cathode. How do you remember this? The direction of this arrow tells me the direction of current. Direction of this arrow tells me the direction of current. Right? So this will be positive, this will be negative. On this, there will be light falling. Photodiode. Generally, for a diode to conduct, you need a forward bias voltage. This is a PN junction diode. Yesterday, when I asked you people in 11, you have done this, you told me no. This was a piece of shock. This is potential barrier or energy barrier. This is a P-type material. This is an N-type material represented by this symbol. This is the diode. Right? The majority carriers in this are holes. The majority carriers in this are electrons. When you connect this P-type material to the positive of the battery, these majority carriers will get sufficient energy to cross over the energy band. These majority carriers will get sufficient energy from the battery to cross over the energy band. Once they cross over, there will be conduction through the junction. This is the simple forward bias mechanism of a PN junction diode. Right? Here what happens is, instead of the battery, light falls on the depletion layer and it will make sure that the depletion layer charges will get sufficient energy to make sure that they cross the energy. So the required energy for the majority carriers to cross over in this case is generally given by battery. Photodiode it is given by light. So it's a simple switching circuit. Light falls on it, there will be conduction of current. Light falls on it, there will be conduction of current. Photo detector or photo sensor. That's why the other names for this are photo detector. It detects light. Right? Photo detector or photo sensor. Basically, its construction is like this. How do they construct the PN junction here? It is a rectangular box-shaped structure. You'll have to practice drawing these diagrams. If they ask for working your question papers quite a few times, the question bank says draw a neat diagram. So drawing these neat diagrams are essential. So take this. This is the P-type material. This is the N-type material. Right. There will be a box-shaped structure here. This will be the glass region on which light falls. The glass region on the P-type, the light should fall. Right. Now there are two names. They call this and this by two different names. Right? One is called diffusion mask. This is called diffusion mask. Right. And this is also diffusion mask. Above that, there is a black region in this region. Right. Silicon nitride coating. Silicon nitride coating. The silicon nitride coating is all over this region. The silicon nitride coating is all over this region. But working principle has got nothing to do with all this. This is a proper glass from which light falls onto the P-type material. This is the energy barrier. It should cross over to the N-type material. This will be one terminal. This will be one terminal. Right? Which am I dealing with? Photodiode. Right. And the other diagram related to this, which they want to show you people, is directly draw the PN junction here. Here the depletion layer will be large, right? This is the P-type material. This is the N-type material. P-type material is connected to the negative. N-type material is connected to the positive. You are intentionally connecting this in the reverse bias so that even by chance there should not be current flowing when there is no light fall. Current should flow only when there is light. 0.6 volts by chance, anytime it can happen. Right? So when light falls on this region, it should make sure that the depletion layer means you will get substantial amount of quantity of charge which will move on both sides and then conduct current. Right? Now there is one small problem here. This is what they asked. The question that they asked is about dark current. You have connected this in the reverse bias so that even by mistake there is no current flowing through. But even when light doesn't fall through in the reverse bias, minority carriers will start getting pushed. The negative terminal is connected to the P-type. Isme there are minority carriers. Minority carriers start getting pushed towards this. So there will be a small magnitude of current even when light doesn't fall onto it. Right? It is a constant value after certain voltage is reached. So the VI characteristic of this will be like this technically. This is I in microamperes. Even when there is no illumination, you will find certain current. Right? This will be called as ID. That is in microamperes. ID, and this is the light intensity. Light intensity. When light intensity was zero, also you are finding some current in it. right? This will be called saturation current. Saturation current. This, when light intensity is 0, you are finding some magnitude of current. That is dark current. ID is dark current. They asked you question on it in the question bank for 1 mark. What is dark current in photodiode? Right. The second thing that they defined is dark resistance that they asked. Dark resistance. 1 second, wait. I wrote this dark resistance. Value of RD. This is dark resistance. Why is it called as dark? Even when there is no illumination, when there is no illumination of light, it's dark. Even when there is no illumination, there is some maximum, some current passing through it. That current is called dark current. Right? This will be IS. Dark resistance, maximum reverse voltage. Maximum reverse voltage divided by maximum reverse voltage is this, divided by the magnitude of ID. The reverse voltage that you applied, maximum value of this divided by the dark current is defined as the dark resistance. On photodiode, they asked 3 questions. One, they asked you to define dark current. Second, they asked advantages and disadvantages. Right? VI characteristics are always mandatory. Here it is light intensity versus current. Light intensity versus current. Milliwatt per centimeter. Units of this are in milliwatt per centimeter. Units are must. Microamperes here, milliwatt per centimeter is there. Light intensity.
So in transistors, there was something like transistor as a switch in NCRT. So will you be teaching that?
We have done that yesterday without your knowledge.
So not the switch. We just did.
See the equation that of the amplifier. And
Yes,
how do
we
you
did
use it as a
amplifier.
switch? The last graph we have done. There is a graph like this.
Yes, sir.
Right? It works as a switch in the saturation. So how does it work? If there is no current, you can use it multiple ways. Starting way there is saturation current, then the current is decreased, then it comes to saturation. Right?
Yes, sir.
So it will work as a switch. When there is no current, it will open up. When there is current, it will close up. So when the current is changing, it's in the active region. Current is constant, it gets disconnected.
Okay, sir.
That is precisely the switch. I'll dictate that also. You can tell. In the transistor, make a note of this and dictate this point. In the transistor, where you drew that graph for transistor, all of you have a look. You drew this graph, right? Active region, saturated region, Did we draw this graph?
Yes, sir.
Yes.
उसके नीचे make a note of this point. When transistor is not conducting, it is in the switched off mode. When transistor is not conducting, it is in the switched off mode. That means which state are you speaking of? First state. First state, there is no conduction, there is no IC. So potential difference will be equal to VCC. Yes or no?
Yes, sir.
Yes, sir.
Full stop. Then write the statement. When it is in the saturation state, it is in the switched on state. When it is in the saturation state, it is in the switched on state. This is saturation, right? So when you are using a transistor not as an amplifier but as a switch, what will you do? The active region you decrease. How do you decrease? By changing the concentration of the dopant. So when you're manufacturing itself, you will know whether you are using this transistor for amplifier or for a switch circuit. Now, decrease this particular region. So in this state, it will be switched off. This state, it will be switched on. Now back to photodiode, there are 4 points which I have to dictate if you are done with this.
Wait for a minute.
Yes.
Done, sir.
Sir, in transistor as an amplifier, what exactly was it amplifying?
See this amplification? This is input voltage, this is output voltage. Right? For a small change in input, there is a large change in the output voltage. The line is steeper. For a small change in input, there will be a large change in the output.
So, but if we just want the voltages to change, then we can also use a transformer, no, instead of this.
Transformer का size कभी देखा है आपने?
No, sir.
Transformer का size will be my height from the ground till my height width will be this. Transistor का size?
Okay. So, but the functioning of a transformer and this is the same, right? I mean,
No. Transformer you cannot use as a switch. This you can use as a switch. Feedback amplification is possible. You can re-feedback into it. N number of different parameters.
Okay.
Now, photodiode, write the first point. Photodiode means first point. Reverse current depends only on concentration of minority carriers. Reverse current depends only on. Technically, what is reverse current? Current flowing through the diode when it is reverse biased. But ajeeb language hai. They should not use this word reverse current. But that's the way your HSC textbook did, so use it. Technically, it is current flowing through the diode when it is reverse bias. They called it reverse current. Actually, such a word don't exist. A reverse current is colloquial language developed, right? Current flowing through the photodiode or diode when it is reverse bias. They are calling it reverse current. So reverse current depends only on the concentration of minority carriers. Reverse current depends only on the concentration of minority carriers. Reverse current depends only on the concentration of minority carriers. Full stop. Next point. This current is called dark current in a photodiode. This current is called dark current in a photodiode. This current is called dark current in a photodiode. This is asked in 4 marks question for you. I'll read out the question. In 4 marks, there were 3 questions on transistors, 1 question on this photodiode. Define dark current of the photodiode. What are the advantages and disadvantages of the photodiode? So when they ask this question, you will write what I dictated now, and then advantages and disadvantages I dictate. But before I go into advantages, write 2 more points in this. What did you write? This current is called dark current in a photodiode. You have written that?
Yes, sir.
In the bracket, you will write in continuation in the same point, as it flows, as in the bracket, as it flows. Even when photodiode is not illuminated, as it flows, even when photodiode is not illuminated. As it flows, even when photodiode is not illuminated. Third point, this is the working. So when they ask you for 2 marks working, these 3 points you will write. The third point is important to explain working of this photodiode. Third point, when illuminated, the reverse current increases. When illuminated, reverse current increases due to large hole electron pair generation. Due to large hole electron pair generation. Due to large hole electron pair generation. For 1 mark, they asked one question. The question was, what is the principle on which photodiode works? It converts light energy into electrical energy. Photodiode converts light energy into electrical energy.
Sir, could you please repeat the definition of the reverse current?
Reverse current is the current passing through the diode when the diode is in reverse bias.
Okay, sir.
Current passing through the diode when the diode is in reverse bias. Advantages of photodiode. Advantages of photodiode. लिख रहे हो आप लोग?
Yes, sir.
First point, quick response when exposed to light. Quick response when exposed to light. Quick response when exposed to light. Second point, reverse current. Have a look at this line. Have a look at this line. It is linearly proportional. So based on the reverse current, you can approximately guess what is the intensity of light because it is linearly proportional. Reverse current is linearly proportional to intensity of light. Second point, reverse current is linearly proportional to the intensity of light. Third point, lightweight and compact size. Lightweight and compact size. Lightweight and compact size. Lightweight and compact size. Next point, wide spectral response from ultraviolet to infrared. Now listen, it is not visible light only. The photodiode is sensitive to even ultraviolet radiation in infrared. Your eye cannot recognize infrared. Photodiode can recognize. Keep a photodiode. If it shows current passing through it, that means radiation is falling on it. Right? Wide spectral response from ultraviolet to infrared. Wide spectral response from ultraviolet to infrared. Are the advantages clear?
Yes, sir.
Disadvantages of photodiode. ये भी पूछा है हम लोगों ने. Disadvantages of photodiode. Its properties are temperature dependent. Photodiode disadvantages. First point, its properties are temperature dependent. Actually, this is the only disadvantage of photodiode. Temperature dependence. It gets heated up, it will behave in a different way. Its current will not be linear. Right? Now, the tricky part is they wanted two disadvantages. So the second disadvantage your textbook has written, low reverse current for low illuminating levels. वो तो quite obvious है. अब you are telling me reverse current is proportional to the intensity of light, linearly proportional. तो अगर intensity of light कम है तो obviously reverse current will be low. You are specially writing that as a disadvantage because you need one more point to write. Fine. This is quite obvious. This is linearly proportional, the reverse current and intensity of light. Right. So when intensity of light is low, the reverse current also will be low. It is no specific disadvantage, but you need 2 points to write, hence you are writing the second point. Low reverse current for low illumination levels. Low reverse current for low illumination levels. Next point, which they didn't give in your question bank, but to be on the safe side. Applications of photodiode, they are huge. Applications of photodiode. Applications of photodiode. लिख रहे हो? First point. Safety electronics like fire and smoke detectors. Safety electronics like fire and smoke detectors. Second point, used as switches. Switch. Used as a switch. Third point, burglar alarm systems. Third point, burglar alarm systems. Fourth point, fiber optic communication systems. Fiber optic communication systems.
So why had we reverse biased it? I mean, even if it was forward biased, we would have got a similar graph of I versus Cam.
A
I would
forward
be
bias
intensity.
means with little bit of a current, with little bit of a forward voltage, it will start conduction. Saturation will reach very fast. Forward bias, we don't want, even in the reverse bias, we are having dark current. In forward bias, we'll have abnormally huge dark currents. Even when light doesn't fall, sometimes in forward bias with little bit of a 0.6 volts, तो कभी भी लग जाएगा circuit. Forward bias too easy. For instance, Zener diode का भी वही तो application. You want a constant voltage. What will happen in the forward bias? This will be the forward bias. This will be the reverse bias. Normal diode. This is 0.6 volts. So this has become too small for us to operate. So the Zener diode में what do they do? Normal breakdown will happen somewhere at 120 volts. Zener diode, the breakdown will happen at 80 volts. This figure is more comfortable to use in the circuit. Neither this nor this. This is Zener diode. This is avalanche normal breakdown. 120 volts तक जाओगे तो there will be conduction in a normal diode. So Zener diode they heavily dope. They dope it heavily and decrease this thickness. P and N. When they decrease the thickness, reverse bias conduction will happen in 80 volts, and that's a comfortable value for your circuits.
Okay, sir. Thank you, sir.
Now, solar cell. Solar cell, they didn't give you the question. They gave you only a 2 marks question. I'll just read out the question, but solar cell कहाँ पर है? Explain the 3 marks question. Construction and working of a solar cell. डायग्राम ढंग से याद रखो, बाकी सोलर सेल में कुछ खास है। डायग्राम में this is the N type, this is the P type material. There will be a small attachment here. This will be negative, this will be positive. Across this you will have current, right? This is called the front contact. This and this knob are called front contact. This neat diagram is a must. Out of the 3 marks for you, 1 mark is given only for the diagram, right? Rear contact, rear contact. This is the P-type material, N-type material, and then you have got an anti-reflecting contact on this top. Now they showed with different colors in the examination. How will you show? I don't know. Do it this way, right? This is called anti-reflecting contact. Why do you need anti-reflecting contact? Solar cell works on the solar energy which falls on it. Solar energy falls on it and it gets reflected. Whole of the equipment will be a waste. So they need a contact which will make sure that reflection is minimal. So this is an anti-reflecting contact layer, and that's a must, which allows visible light to pass through it, right? The main function of this coating is to reflect IR radiation and protect the solar cell. See, now the problem with all these semiconducting devices is once they get heated up beyond a limit, their parameters will change. VI characteristics will change. So unnecessary heating should be prevented. So this anti-reflecting contact, there are two main jobs. One, permit visible light, and reflect heat radiation, that is infrared radiation. Those part of the wavelengths of light which heats up the substance quickly should be reflected, and visible light which doesn't heat up the substance very quickly should be permitted. So anti-reflecting coating is a very significant part in this particular working. It should permit visible light and it should reflect infrared, which heats up the material to a very great extent. First take it down till here. We'll have to draw one more diagram. This is the construction.
Sir, sir, IR is infrared radiation, no?
IR is infrared radiation, right?
Okay. Thank you, sir.
This voice appears familiar.
So, Neil.
Right. Thane, right?
Yes, sir. Thank you.
कैसे हो?
हाँ सर ठीक हूँ सर, आप कैसे हो?
मैं तो ठीक हूँ। आपने भूल गया, आया था मैंने थाने तेरे लिए।
नहीं सर, तभी सर दिन ठीक नहीं था। Third wave was also going on, so that next time we will surely meet.
15 से प्रैक्टिकल एग्जाम शुरू हो रहा है आप लोगों का. Prepare well.
Yes.
Schedule is being fixed. Yesterday I was there in Andheri. They were doing the brainstorming for that.
Yes.
Sir, तक पता लग जाएगा प्रैक्टिकल शेड्यूल के बारे में?
प्रैक्टिकल टाइम टेबल बना रहे हैं लोग,
अच्छा,
batch wise, section wise. No, there are so many rules. Students will be made to sit in a classroom. One by one they'll be called because all of them cannot be crowded in one place. रूल्स तो जबरदस्त बना रहा है, अब स्टूडेंट्स कितना फॉलो करेंगे वहां कितना होगा पता नहीं, बट रूल्स आर बीइंग मेड स्ट्रिंजेंट. Let's generally practical lab में we used to have a huge batch in one lab. नहीं, all centers they are making these rules. They'll be made to sit, social distancing, all this, but ultimately students should follow that.
sir, between each practicals we will have holidays, right?
Pardon?
Between each practicals we will have holidays, right?
You know, oh schedule.
Yes, sir, between practicals we will have holidays.
Holidays in between practicals means continuously. That schedule I have no idea. I didn't see that schedule making which batches. And you will have a gap to my knowledge because they have to accommodate many students, right? There will be a gap. But I didn't see that schedule. That I have no idea. Now this is the construction diagram for solar cell. Right. This is the working diagram. Have a look at it. It will have a larger depletion area. Right. This will be N type. This will be P type. Front contact, rear contact. Right. See, they played with the wording here. Material used for fabrication में two important characteristics होना है. The material used in fabrication में two important parameters. Right? The electrons should rise up. The positive holes should move down. So after drawing this diagram, the two main characteristics that the material should have, write down both the points. First point, material used for fabrication must be photosensitive material. Material used for fabrication must be photosensitive material.
Should or must?
क्या फर्क पड़ता है भाई, दोनों एक ही है. Should be photosensitive material or must be photosensitive material. Second point, higher energy electrons generated should be taken from the solar cell to the external circuit. Higher energy electrons generated should be taken from solar cell to the external circuit.
Can you please tell we are writing these points for what title?
Solar cell.
Okay, sir.
Solar cell में characteristics of the material used for manufacturing. Material use. The material used should be firstly photosensitive. Second, higher energy electrons generated, higher energy electrons generated should be taken from the solar cell into the electrical cell. Now in the construction we showed to you that light will fall on the anti-reflecting surface and then on the n-type material. Here we didn't show the anti-reflecting surface. N-type material it falls. There are whole electron pairs generated. Right? The material should be so designed that the electrons will be moving to this part of the circuit. Positive holes will move to this part of the circuit. Now that working principle is much beyond your scope, so they didn't get into. All that they are emphasizing on is the higher energy electrons should reach this end, the holes should reach this end. This potential difference will make sure that there is current passing through the resistance. The carriers are accumulated across the polarities of the solar cell. This current is called light generated current. Now, it may sound very silly and funny that we give importance to these names. The questions they are asking are that what is light generated current in a solar cell? That's the current. That's not the current flowing inside this. That's the current flowing in the external circuit. How is current flowing in the external circuit? Negative charge is accumulating here. Positive charge is accumulating here. From the depletion layer, the charged carriers are pulled to this point and this point. Once the accumulation happens, there will be current. It is not the same negative and positive flowing through. The accumulation happens here and here. So that potential difference will maintain a current in this particular resistance.
So could you please repeat the third point that carriers are accumulated?
Carriers accumulate here and here. Once they accumulate, they maintain a potential difference across the resistor. Carriers, the positive and negative carriers accumulate here and here. Right? See, I also committed a mistake with the direction of current. Current will be from positive to negative.
Okay, sir.
No, only one line. Listen. The mechanism of how the carriers are accumulated here is slightly beyond, but emphasis on this statement was given by both NCERT and HSC textbook. The separation of the carriers. Now you see you're generating whole electron pairs with the incident light. The separation is possible due to intrinsic electric field of the depletion layer. Separation of these charged carriers. You should separate them, accumulate positive here and negative here, right? That is what happens for a solar cell. That separation happens due to intrinsic electric field of the depletion layer. एक statement लिख दो working में. Separation of the whole electron pairs or carriers generated from the incident light happens due to intrinsic electric field of the depletion layer. Separation of whole electron pairs happen due to intrinsic electric field of depletion layer.
So what after intrinsic?
Pardon?
What after intrinsic?
Electric field.
Okay, electric.
Intrinsic electric field of the depletion layer.
It is whole electron pairs, no?
Pardon?
It
Whole
is whole
electron pairs. Whole electron pairs.
Okay. Thank you, sir.
By the way, just for your information, in this construction, if you see the construction mechanism, N-type material was shown very thin. P-type was quite wide. इसका previous diagram देखो. N-type बहुत thin दिखाई दिया. P-type was quite wide. Yes or no?
Yes, sir.
Why? Because the incident light should reach the depletion layer. Incident light should reach the depletion layer. N-type is incidentally kept thin so that the incident light reaches the depletion layer. If not, I will have trouble in sending the incident light up to the dip, and light must reach the depletion layer. Mechanism is light falls on the depletion layer. The bound hole electron pairs are separated because of the light energy. The intrinsic electric field will pull the electrons to the upper part and positive holes to the lower part. That maintains a potential difference which will maintain current in the circuit. Simple. Light should reach the depletion layer, generate whole electron pairs. These whole electron pairs will have to move to the negative and positive sides with the help of intrinsic electric field. That maintains a potential difference and hence current in this. इसका VI characteristics का diagram याद रखो. The diagram, bus memorize it. Complete explanation is difficult. This will be I, this will be V, right? Draw a rectangle like this. The values are important here. Right? Operating current is 5, this is 4. In milliamperes, here it is 17, right? And 20. One second. Sorry, make change. This is amperes. Amperes and this is volts. Solar cell ka, just remember this. Draw a rectangle this way. This is 17 volts. 4, this is ideal, but in practical reasons, that's the work. You will have for 20 volts 5 amperes of current. This is the short circuit current. When the voltage is 0, it's called short circuit. Short circuit. When the voltage is 0, it is called short circuit. This will be open circuit. When there is open circuit means what? You have the solar cell and you didn't connect capital R. You have the solar cell. You have the negative here, right? You don't connect this. This resistance is not connected. This is open circuit. At open circuit, what is the potential difference across the solar cell? It will be 20. You connect this, the current will be maximum of 5. So short circuiting, if the resistance is negligibly small, then the current flowing through is 5 amperes. If the resistance is negligibly small, then the current flowing through is 5 amperes.
So the ideal one is at 4 and 17. No?
Yeah.
And that is a real one, no? Like actual.
5 and 20.
Okay. Thank you, sir.
No. They ask for definition of logic gate. That sounded very funny for me. But they have given in your question bank. Logic gates. They asked for the definition. Write down the definition. This is important. वो 1 mark के लिए पूछा हुआ है क्वेश्चन बैंक में और पूछेगा. A digital circuit. A digital circuit with one or more input signals. A digital circuit with one or more input signals, but only one output signal. But only one output signal is called a logic gate. Is called a logic gate. First gate is a NOT gate. It is also called as inverter. Inverter. Why? The first logic gate is like this. NOT gate, if the input is X, output is Y. Y is equal to X bar. Easiest possible thing is input, output. If I have 0, this will be 1. If I have 1, this will be 0. The construction of this using transistors is a very interesting topic. But you don't have that in any of your textbooks, HSC textbook. So we'll skip that as on date. But how do they construct this using a transistor is quite interesting. If it becomes +5, it will be 1. 0, it will be, if the potential drop across the load resistor is greater than 2 or 3 volts, it will show that as 1. Anyway, don't get confused with all that. What they're asking in your HSC will stick to that. NOT gate, also called as inverter, output will be X bar. right? This is called the truth table. To my knowledge, all of you would have been well versed with these gates. OR gate, technically gate should always be written with capital G. Technically gate should always be written with capital G. OR gate, OR. Symbol is like this. OR gate. You will have multiple A and B. Output, call it as C. Right? This will be A plus B. OR gate will be A plus B. But then this is A, this is B, this is C output. 0, 0 will be 0. 0, 1 will be 1. 1, 0 will be 1. Only in digital 1 plus 1 will be 1. So the output of an OR gate will be 0 only when both of them are 0. Remaining all situations output will be 1. For a change, I'll show you the realization of OR gate. How do they realize this using diodes? How do they construct this using diodes? I'll show you that for OR gate. It is a very basic structure in electronics. In your mathematics or other systems, they show you this as one gate like this and another gate like this. In the sense, two inputs A and B. This will be a 5 volts battery. This will be the load resistance R, across which the measurement is done. Right? You keep both of them open, 0 and 0, there will be no current. You keep any one of them closed or both of them closed, there will be current. So potential drop across this will exist, whether A is closed or B is closed or both are closed. When it is closed, you call it 1. When it is open, it is 0. So when any one of them is closed, any one of them is closed, or both of them are closed, I'll have potential drop across R. This is what mathematically they say. How it is realized in physics using diodes, I'll show you that. Can I rub the board?
Yes, sir.
You have a diode D1 here. Call this diode D1. This switch can be thrown between A and B. I'll call this A. This will be grounded. This will be 5 volts. This will be B. Right? No, B is the other input. Now, I have another diode here. This is 5 volts. This is B. This is A. Right? This is R. Now this is taken to be 0. This is grounded. This is 1. 0, 1. When I place A on this part, this is P type, this is N type. When P type is connected to positive terminal, it will be conducting. When P type is connected to positive terminal, it will be conducting. So when I place A here, this is 1. There will be current flowing through. Potential drop across, this is 1. When I place B, the B switch here, this will be conducting. This is B2. If it is conducting, there will be potential drop across this. Answer is 1. If the output potential is greater than 0, the answer is 1. Now, if both are kept at 0, neither of them will be conducting. Neither of them is conducting, no current across this, no potential drop, 0. If both are placed at 5 also, there will be current flowing through it. The answer will be 1. This is the way they construct an OR gate. This is just for your understanding. JEE mains also, they are not asking you anything related to the realization of the gate. How do you construct the gate? They didn't. They are strictly sticking to they are combining two gates. That's it. OR gate, NOR gate. They are combining two gates. They are asking for the out. That are two very simple systems.
Sir,
Hmm.
so the name of the diagram is construction of OR gate using diodes, no?
Realization.
Check
Realization. Realization of OR gate.
Okay, sir. Thank you, sir.
Done, sir.
AND gate. A, B, C. Right? AND gate will be A dot B, truth table. A, B, C is output. 0, 0 will be 0. 0, 1 will be 0. 1, 0 will be 0. 0, 1, 1 will be 1. Only if both are at 1, there will be an output. How do you actually realize this? This is a 5 volts battery. You have A and B. Only if both are closed, I will have an output. Only if both are closed, both will be 1. Only then I will have an output. Any one is open, I will not have an output. The three first basic gates.
Sir,
Hmm.
sir, I doubt that the order of inputs will be this, 0, 0, 0, 1, 1, 0, then 1, 1, or can we change?
Reverse way, I have no problem. Suppose you write 1, 1 here, then this will be 1. Write 1, 0 here, this will be 0. I have no problem. Input should be given only in one sequence, no, nothing of that sort.
Because sir, those board people say that there should be an order, something different.
Makes no difference. Just follow the order, it will be more systematic, that's all. But for that, I can make this 1, 1. I can put 1, 1 in the top. What's wrong in the two? Put 1 and 1 here, it will be 1.
Okay, okay. Thank you, sir.
The reason why they say that, just for your information, the people who are evaluating the question papers,
Yes.
they'll be given bundles of papers. Bundles. एक नहीं दो नहीं. इतना bundles मिलेगा. Right? The
Yes.
speed at which they are correcting, if you have ever seen, today you have got counting machines in the banks.
Yes.
Previously, banks didn't have counting machines during your childhood. If you see the cashier counting, his hands will be moving this fast.
Yes.
You cannot count at that speed, but they'll count. Paper evaluators also are doing this job for the past 15-20 years, each one of them.
Yes.
So they'll be, all of them will be sitting, they'll be talking, chatting, they'll be turning the papers so quickly that you cannot imagine. It is beyond your imagination. So for them, at one glance, they'll know whether you have written it correct or not. If you follow a sequence, you are helping them to follow, give marks. That's all. So write in the sequence in which it's given in HSC textbook so that they will not bother to look into every small detail. Then re-evaluation apply karo, then they verify, then they give you mark. Hence they tell you follow one sequence.
Okay, okay. Thank you, sir.
Keep this in your mind when you're solving the paper. What does the examiner want to see in your paper? लिख लो marks तुरंत मिल जाए.
Yes, right, sir. Thank you, sir.
NOR gate. NOR gate is not or. NOR gate is not or. OR gate के सामने not रखो. This is OR gate. Right? Technically, NOR gate is not OR. When you combine both, the gate is shown this way, with this circle. This is not OR. This is A, this is B, C. Technically, OR gate was A plus B, not OR. It will be the reverse this way. What will be the truth table? A, B, C. 0, 0 should be technically 0, but because of this becomes 1. Agreed? 0, 1 should be 1. This becomes 0. 1, 0 will become 0. 1, 1 will become 0. Agreed?
Yes, sir.
Yes, sir.
Can I rub the board?
Yes, sir.
NAND gate. N, A, and D. This is not AND gate. Technically not AND gate. This is A, B, this is C. That means the diagram comes this way. A, B, C is A dot B with a bar. Truth table A, B, C. 0, 0 will turn out to be 1. 1, 0 will turn out to be 1. 0, 1 will turn out to be 1. 1, 1 will turn out to be 0. Not AND gate.
Sir, NAND and NOR logic gates are universal logic gates, right?
Right. Universal logic gates. No. I think only the first three are universal.
No, so NAND and NOR are new.
Can I rub the board?
Yes.
Exclusive OR gate. It has quite a few applications. Exclusive OR gate, or this is written as XOR gate. Its Boolean algebra is C is A bar dot B plus A dot B. A bar dot B plus A dot B bar. The symbol goes this way. This is A, B. This is C. Right? Truth table A, B, C. 0, 0. Have a look at it. 0 with a bar will become 1. 1 dot 0, this is 0. Right? A, I put 0 as it is. B is 1. This will be 0. Yes or no?
Yes, sir.
1, 0. Put in this. 1 will become, A is 1. 1 will become 0. Dot, B is 0. Plus, 1 is kept as it is. B ka 0 became 1. So the output will be 1. 0, 1 will again be 1. Right? 1, 1 will be 0 because when you are changing any one of them into 0, here you will change A to 0, here you will change B to 0. Product will become 0.
So same values will yield as 0 and different will yield as 1, right, sir?
Right.
Okay, thank you.
Now listen to one important instruction. We have one lecture tomorrow and one lecture day after tomorrow. Am I right? See the timetable and tell me.
So we have one lecture tomorrow on Wednesday, one lecture
tomorrow
Friday.
morning.
And one on
Friday morning. Friday morning, I mean 9:45 to 11:45.
Friday morning. Right. Friday's class, I will take what you people said, wave optics that I have written here. Specifically, I'll emphasize interference are not bother about, you will be able to do diffraction and polarization, right?
Yes.
Yes, sir.
Because
Yes, sir.
getting complete experiment, interference, coherence, वो सब कर लेंगे आप by default, right? Only thing you will require is diffraction and polarization. Diffraction and polarization में कुछ निकाल दिया गया है आपका सिलेबस से या दोनों है?
सर दोनों ही लग रहा है मोस्टली, दोनों ही मोस्टली है
right? Either way, before I take Friday's lecture, I'll talk to your college faculty. I'm in touch with them. I'll talk to them. Only those topics which they're emphasizing on, I'm dealing, right? And I'm seeing the question bank that board has provided as well. Strictly, I'm following the question bank. आपको वहीं से questions आएंगे. Nothing to worry about. Tomorrow morning 7:30 we will not have a lecture unless you people are keen on having EMI. Yesterday somebody asked EMI.
Yes, sir, I had asked.
EMI, do you need help?
Yes, sir.
Yes, sir.
Then tomorrow morning 7:30 we'll do EMI. Friday's
Okay.
lecture we'll do wave optics.
Sir?
Diffraction and polarization.
Polarization is omitted.
ये तब तो काम आसान हो गया, सिर्फ डिफ्रैक्शन है.
सर
हाँ,
तो आप करंट इलेक्ट्रिसिटी करवा सकते हैं, सब प्रैक्टिकल में बोले हैं उधर से आने वाला है, उसका रिवीजन करा.
करंट इलेक्ट्रिसिटी थ्योरी और प्रैक्टिकल्स.
सर थ्योरी सर उन्होंने बोला आप टेक्स्ट बुक रीड कर लो, उसमें से वाइवा आ सकता है.
सर वो पोटेंशियोमीटर बहुत इजी है सर, मतलब वो इतना भी कुछ मुश्किल नहीं है. हो जाता है.
माय नॉलेज करंट इलेक्ट्रिसिटी से इलेक्ट्रोमैग्नेटिक इंडक्शन तक यू पीपल अगर क्वेश्चन बैंक देखेंगे तो भी आपका हो जाए. इट्स क्वाइट इजी. एनीवे, नाउ लिसन, डोंट वरी देन, इतने सारे नहीं होंगे. टुमारो विल डील विद इलेक्ट्रोमैग्नेटिक इंडक्शन, राइट? फ्राइडेज लेक्चर विल डील विद डिफ्रैक्शन.
Okay, sir.
Is that clear?
Yes, sir.
Yes.
Yes, sir.
Tomorrow EMI, Friday's lecture, diffraction. I'll talk to your college faculty before we jump to conclusions and not assume that polarization is removed. Depending on, they are in regular touch with the college groups, rather they get email from the board. From the board, official instructions they read. So let us take first-hand information from them. So board sends official informations to the college, which are conveyed to the respective faculty. So I'll talk to them before we jump to conclusions. So tomorrow we'll deal with EMI then. I'll have to go through the question bank that they have given, but EMI should not be difficult. Yeah, what all are removed from EMI? Right. Tomorrow we'll deal with EMI. Fine.
Yes.
Yes.
See you people in tomorrow's class. Good day. Bye.
Bye sir. Thank you.
Thank you, sir.